This is the third video on the derivative, and what we're working with is the function f of x equals x squared minus 3. That was a parabola opening upward, and we were trying to find the slope of the tangent line at the point 1, negative 2, and we were using the definition for the slope of a tangent line, which is m equals the limit as h approaches 0 of f of c plus h minus f of c over h. Remember, this formula came from the formula for slope, and c is the x value in the ordered pair. So we went ahead and went through this process, and we ended up with a slope of 2 because the limit as h approaches 0 was 2. So remember, our function was f of x equals x squared minus 3, the parabola opening upward. And using the definition for the slope of the tangent line, that was the formula, the limit as h approaches 0, etc., we found that at the point 1, negative 2, the slope of that tangent line was positive 2. So if we wanted to, we could use the point slope formula to find the equation of the tangent line. So let's just do that. Remember, the point slope formula is y minus y1 equals m times x minus x1. And if you did want to use that formula, then we would have y minus y1 is negative 2. The slope is 2, so we put that in for m. And x1 is positive 1. That comes from the ordered pair. So we have y plus 2 equals 2x minus 2, or y equals 2x minus 4. So now we're going to go back up to our original picture of this graph and see if it makes sense that looks like that would be the equation of the tangent line. This is where we started. We considered the function f of x equals x squared minus 3, and then we were just estimating where the tangent line might be at the point 1, negative 2. Remember, we said the tangent line down here, the red line, it looked like the slope at 0, negative 3. The slope of that tangent line was 0. And then we were trying to find out what the slope of this green line is. So we were trying to draw a tangent line. And so the question, does it look like it is what we just came up with? We came up with y equals 2x minus 4 for that tangent line, and actually that's what it looks like. It looks to me like it did go through a y-intercept of negative 4 and a slope of 2. That was an approximation. We could have been off a little bit, but for my picture we sort of get the idea. So the slope of the tangent line was 2, and the actual equation, if we wanted to use the slope point formula, let's look back at the definition of tangent line with slope m. We took this limit as h approaches 0 of f of c plus h minus f of c over h, and if it existed, it equaled m, then we say that the line passing through that ordered pair, c, f of c, with that slope m, whatever you get when you apply the limit, that is going to be the slope of the tangent line to the graph. Now what's interesting is we're going to now go on to the formal definition of a derivative. It's going to look exactly like that. The difference is, instead of you'll seeing this letter c, we're going to have an x. So c was a particular value of, in an ordered pair. So here's the formula you've been waiting for. The derivative of a function is the definition. F prime of x, that's the way we read this. F prime of x is equal to the limit as h approaches 0 of this difference quotient. Remember, this had to do with the formula for slope. F of x plus h minus f of x, that was the difference of the y values, and at the bottom we originally would have x plus h minus x, so we end up with just the h in the denominator. So that is the derivative. So if you have any ordered pair, x, y, you could plug in the x value into this f prime of x, take the limit, and you'll be able to figure out the slope of the tangent line to the curve at that point on the curve. So let's do it for the problem we've been working on. We've been working on f of x equals x squared minus 3. And just notice we're going to have to take a limit as h approaches 0. And in that limit, we're going to also have to compute what f of x plus h is. So to make it easier, let's just compute f of x plus h. So we're going to plug in x plus h for x. And you're going to square the binomial. Remember, it's x plus h times x plus h, so that's x squared plus 2xh plus h squared minus 3. So we know f of x, we know f of x plus h. Now we're going to plug that into the formula to get the derivative. So we've got f prime of x is equal to, okay, all right, it says we're going to plug in, oops, I forgot, it's got to be the limit. Don't forget to write the limit as h approaches 0. And in the numerator, we're going to have f of x plus h, which is this x squared plus 2xh plus h squared minus 3, minus f of x, up here is f of x, which is x squared minus 3, and all of that is going to be over h. All right? All right, we have to keep going. Let's write that as the same thing. I have to remember you have to keep writing the limit as h approaches 0. And let's simplify the numerator. So I have x squared plus 2xh plus h squared minus 3 minus x squared plus 3 when I distribute the minus sign. And in the numerator, let's see, the x squared minus x squared cancels, the negative 3 plus 3, I end up with just 2xh plus h squared over h. This should look familiar. It's almost like what we just did a few minutes ago. I think I'm going to go down the page still. Equals the limit as h approaches 0. Let's see. I'm just going to show the factoring here. H times 2x plus h all over h. See how the h's cancel? So I really end up with just 2x plus h. Which if you plug in, now you could plug in 0 for h. That's the first time you don't have to write the limit. So you have 2x plus 0, and the answer is 2x. See the difference? This time I got 2x. All right, so what does this mean? We had this function, f of x equals x squared minus 3, and we now just came out with f prime of x was equal to 2x. So what that means is at any point on the curve, if I want to find the slope, I could plug in the x value and it'll tell me the slope. Kind of interesting, don't you think? So let's look back at our graph. Here is our graph. Here's our original function, f of x equals x squared minus 3. What it says is f prime of x equals 2x. So at any ordered pair, we should be able to tell the slope of the line if we know the ordered pair. So here's an ordered pair. This was our ordered pair 1, negative 2. And what happens? When we plug in 1 for x in the f prime of x, you get 2. So that's why the slope of this line was 2. How about this ordered pair down here? It was 0, negative 3. And here the x value is 0. If you plug in f prime of 0, you are going to get a slope of 0, which is what it looked like. Now, let's say we were going to do this point over here. This was negative 3, 6. and I want to know the slope of this line. That looks pretty steep, and it also looks like a negative slope. If you plug in -3 for x, you're going to get a slope of -6. So this tangent line, wherever it is, it's going to be very steep, hard to even see it, has a slope of -6. And that's all about the interesting part of finding the derivative.